Okay, we are doing 11.3, 11.5 today. So again, yesterday we did prisms and cylinders, and today we're doing pyramids and cones. There's still 3D shapes. There's still a pyramid is still a polyhedron, just like a prism was. But in this case, it only has one base that's a polygon, and its lateral faces are instead triangles. And the last one, the lateral faces were all rectangles, but today they are all triangles because they have a common vertex. They only have one base, and then they go from that base up to a point, and so that makes it a lot of little triangles. The intersections of the two lateral faces is called a lateral edge, and the intersection of the base and a lateral face is called the base edge. That's not a super common thing that we're going to talk about. It's just like a good thing to know and have like mentioned essentially. If you come look at the picture, my base is this quadrilateral in the bottom, and my base edge is one edge that touches the bottom and touches one of the slant sides, while my lateral edge goes like along the triangle. So it's one of the sides of the triangles. Yeah, Caleb? What'd you say? On this one there are, but not necessarily always. So the base is like kind of the special shape that happens. It could be triangles, it could be a hexagon, it could be a pentagon, it could be a square, it could be a bunch of different shapes. In this case, there's 4 base edges. And this is a pyramid. The perpendicular distance between the base and the vertex is what we call the height of the pyramid. So the height is not that lateral edge that I just traced. It's if I took it from the vertex down to a spot that is perpendicular to the base. We're going to draw a height on another shape, but it's kind of like if I were to drop a string down, right down the middle. Is it the State Museum that has that like pendulum that like swings back and forth and it like knocks down those little like blocks that when the time passes and when the earth rotates? Somebody. Wait. Okay. Wait. I think it's the State Museum downtown. There's like a big pendulum. So it's like a ball at the end of this string, and it's like around it, it's a circle at the bottom, and it has these little pins up. Yeah. And then as like the earth rotates and as time passes, it like knocks little pins over. So it's like a pendulum. If the pendulum were to stop, that would be like the height. Yeah. I was wondering if someone was going to come back for that. You're so welcome. So I think of the height like the pendulum that just like stopped down. It's not when the pendulum's pulled all the way over. It's like straight down. It's like not swinging. All right. A regular pyramid is a pyramid whose base is a regular polygon. So it could be an equilateral triangle. It could be a square, or it could just be a regular hexagon or a regular pentagon or something like that. A regular pyramid has a regular polygon as its base, and its height meets the base at the center of the polygon. So the height, this spot right here, that where the height touches the base of the polygon, that's the same distance all the way around. So like from vertex to vertex, that's the same distance. If I was to go like across, this would be the same as like this distance. So it's just right smack dab in the center. The slant height of the regular pyramid is the altitude of any triangular face. So that's like if I took one of the lateral faces and took it off of my pyramid and then found the height of that 2D triangle. So slant height is this blue line, and then the height is like the red line. Do you guys kind of see the difference? What we're going to do in a little bit is we're going to connect it, and we're going to know what this distance is. And then I've got a little right triangle right here that's going to help me find one of the distances that I don't have. So I'm kind of just previewing us. We're going to get there eventually, okay? The slant height and the height are different. For our formulas, we're going to use these 3 letters. We've already used big B for area. We've already used big P for perimeter, and we've already used little h for height. The new letter I'm going to teach you is little l. The lowercase l is what we use for slant height. I guess because S looks a lot like 5, so we just decide not to use a variable that looks like a number that we already have. Cursive L looks a little bit different. All right, time for formulas. Lateral height is the sum of the area of its lateral faces. Oh, Jesus. Okay, let me try again. In this case, it's a bunch of little triangles. So because of that, my lateral area has 1/2 out front because the area of a triangle is 1/2 base times height. So I'm going to multiply 1/2 times the perimeter of the base times, and I'm going to multiply it by the slant height, not normal height. Because we're just finding the area of the triangles. Well, the height of the triangle is that slant distance. The height of the entire prism, I'm going to have to use for volume, but that's it. I use slant height when I'm doing lateral area. So in that case, I think of it as a little shortcut, 1/2 PL. Okay. Surface area is the same thing as what we did before. It's LA. But instead of it being plus 2B, how many bases do I have this time? Just one, right? So it's just going to be plus B. Okay. And the volume of a period, or volume of a prism, sorry, period's a word that we use in pre-cal for graphing, so I don't know why I thought of that here. Volume of a pyramid is the area of the base times the height of the pyramid. So just like in a prism and in a cylinder, it's base times height. This time it's 1/3 base times height. I'm sure I could like derive that for you. I just don't know it off the top of my head, and I'm not going to do that. We don't have time for it. So just remember 1/3 base times height for volume. The examples were, or at least the first example, we're not going to do volume though, so we don't have to worry about that. Anybody questions? So now you have all the formulas. We're going to walk through the first one together, and then I'm going to ask you to try the other one on your own. So this first example, find the lateral area and surface area of the regular square pyramid. What base do I have? What shape of a base do I have? Square. Mm-hmm. And I know it's specifically a square because it's a regular polygon. So it's not just any quadrilateral, it's actually a square. So that means all these little sides are 20. What's my slant height? 30, very good. 30 millimeters. Perimeter of my base, I'm going to do 20 times 4, which is 80 millimeters. And then area of my base, how do you find the area of that square? (20 times 20), which I believe is 400. I'm only doing LA and SA, so these are the 3 things I need. Anybody have any questions on what I've done so far? No? Okay, let's do it then. Lateral area, I just told you a second ago, is 1/2 PL. So I'm going to do 1/2 P, we said was 80.
Interruption. At this time, could you please release any choir members that you have in your class so that they can be dismissed to board the buses in front of Loretto? Thank you.
Is that anybody in here? All right, carry on. So I'm going to do 1/2 80 times 30. Remember, you only have to do 1/2 of one thing or the other. You don't get to do 1/2 of 80 and 1/2 of 30, just 1/2 of one of them. I wrote 80 first, so I'm going to do 1/2 of 80, which is 40. 40 times 30, I believe, is 1,200 or 1,200 millimeters squared. Cool? Everyone good so far? Remember, surface area is just LA plus B. So I have LA, 1,200, plus B is 400. That makes it 1,600 or 1,600 meters squared. I didn't ask you to do volume in this one, and we will do one next round, but not this time. All right, anybody questions? Can you take a second and try the next one? And I'll join you momentarily. I'll leave this up for a second. Okay, we'll finish up where you're at. This one is a little bit harder. I gave you a hexagon. And I wanted to see, did you remember how to do that? I do. Stay in there, buddy. So I've got my base is a regular hexagon. My slant height is 18. My perimeter is also super easy. All the sides are 8 and there are 6 sides, so 8 times 6 is 48. So I'm killing it on the first two. Area of base though, I redrew that picture for you. I redrew the base as a 2D shape, hopefully to make it look a little bit nicer. I know that I've got these little equilateral triangles, so all of these sides are 8. What does that make this side right here? 4. And what does that make my height? What do you do to go from the short leg to the long leg? Perfect. Multiply by root 3, I've got 4 root 3 inches. That's the same box as this up here. Those are both 4 root 3 because it's pointing to the same line. Area of the base is going to be 1/2 of my base, 8 times 4 root 3. And then whatever that answer is, I'm going to do 6 times it. Because in my hexagon, there's 1, 2, 3, 4, 5, 6 little hexagons, or little triangles, excuse me. Okay, 1/2 of 8 is going to be 4. 4 times 4 root 3 is 16 root 3. And 6 times 16 root 3 is 96 root 3. Okay. Any questions? Any thoughts yet? Okay, now we're going to go plug those in to find LA and SA. Take a second to do that. Reminder, MLA is 1/2 PL. 48 times 18. $432. Surface area, I can't combine 96 root 3 and 432, so I'm just going to add them up instead of next to each other. 432 plus 96 root 3. All right, how are we doing? Everyone's hanging in there? Okay. I think next we're ready to talk about cones. You guys ready for that? All right, let's move on to cones. This one says a cone is a solid that has one circular base and a single vertex. So that means it's just like an ice cream cone. It's very descriptive, and we have things in our real life that look like that. So we know that that's a cone. My vertex is this kind of top point that it connects to, and then I've got a circle at the bottom. The cool thing is that like my slant height is the same all the way around because it's from the vertex to a point on the circle. I know it looks like it changes, but that's because it's hard to put a 3D figure on a 2D shape. So all of these places I've got this red line, these are all the same distance. So that's kind of a cool thing we've got going on with cones. The height of the cone is the perpendicular distance between the center of the base and its vertex. So I've got my height labeled as H, and B I can know is my center because the height goes from the vertex down to the very center. The radius is the radius of its circular base, and the slant height is the same concept as the slant height in the pyramid. So that's my lowercase cursive L right there. Cool. For every cone, the area of a base is a circle. So the area of a circle is pi r squared. And the perimeter of a base is 2 pi r. Okay, what I'm going to do for all of these is I'm going to tell you what like the formula would be if you just think about it like we've been thinking about all of my other shapes. But just like yesterday, I'm going to put it in terms of just circles. So you can use one or the other. I'm going to use the general one just so that I only have one thing to remember, but you can use whichever one you want. So you'll see what I mean in a second. The lateral area is the area of its curved surface. So that's 1/2 times the perimeter or the circumference of the circular base times the slant height. So that's 1/2 of P times L. I will personally probably use this. This makes more sense to me to just do P. We've been practicing that. We've been doing that. That's what I'm going to do. What you could do, though, is you know that P is the same thing as 2 pi r, right? And L is my slant height. And so I can simplify that one step further. If I do 1/2 of 2, I'm just left with 1. So I get pi r L. So some people are like, oh, well, if I don't even have to find perimeter and I can just do pi times r times L, great. I personally just can't remember all those things. I have to get some things out of my head. I can't remember that. So I'm going to do 1/2 PL, but you can do the other one. This one's also okay. Surface area is the exact same idea, area of one base plus the lateral area. So I'm going to use LA plus B, again, like we just spent, 5-10 minutes practicing. Or you could think of it as LA. A minute ago, we just wrote that as pi RL. And then base is just pi r squared. So again, you're welcome to use those. I just personally won't remember it. And I think it's easier to identify height, slant height, perimeter, and base first, and then plug all of those things in. Similar, last thing is volume, except I did mess up on volume. Make sure it says 1/3 BH. And so when I put that in terms of my area of my base as the area of my circle, it becomes 1/3 pi r squared h. Again, both of those are fine. I'm going to do the highlighted one. So. I feel like we're flying through this. Did I miss something? Am I moving too fast? Why does it feel like we've got so much class time left? We just didn't play around today, I guess. That's not a dig on you guys. Last class we like barely finished, and I looked up waiting for it to be like 15 minutes left, and we got like 30 minutes left. So, okay, great. Well, maybe you guys will have time to work on homework and then you won't have to work on it at home. Okay, awesome. Let's go us. I'm going to do one example with you, and then I'm going to be quiet, and I want you to try this example, okay? So I've got this. Completing the following, express my answers in terms of pi. Okay. It does not list p here, but I am going to solve p right there. So I just kind of put like a little break right in between b, and I'm going to do p over here. What's my radius of this picture? 6. What's my, do I know my height yet? No, I don't know my height. I do know my slant height though. What's that? 10. Let's actually team time out and do my height first. Okay, I'm going to zoom in on the picture. I'm going from the vertex down to the center. Do you see I've got a little right triangle right here? Can you find h? How would I do that? Pythagorean theorem, very good. What's my c in this one? 10, very good. Okay, so I'm going to do h squared plus 6 squared equals 10 squared. Nice, I got a nice easy answer. I got 8 feet when I did my Pythagorean theorem. So that means my height is 8 feet. That's a nice, easy answer. I don't even have to do any square roots or anything. Everybody cool with that? All right, now let's find my base and my perimeter. Remember, perimeter is 2 pi r, so that's 2 pi 6, which is 12 pi feet. And then my base is pi r squared, which is going to be pi 6 squared, which is 36 pi feet squared. And I'm going to have to use all 4 of these to find the next 3 things. Reminder that LA is 1/2 P times L. SA is LA plus B. And then volume was 1/3 B times H. So for LA, I've got 1/2 times 12 pi times L, which is 10. One half of 12 is 6, so 6 pi times 10 is going to be 60 pi feet squared. SA is LA plus B, so that's 60 pi plus B, which was 36 pi. So that's 96 pi feet squared. And then last volume is 1/3 base, which is 36 pi times height, which is 8. 36 divided by 3 is 12, and 12 times 8 is 96. So I've got another 96 pi. This time it'll be feet cubed. Okay. All right, I'm gonna be quiet for a minute. I want you to try the next one. All right, guys, take a second. You ready to talk about it? All right, if not, let me talk about H, L, B, and P first, and then we will talk about what's left. This time I actually have my H. I have my 15 meters. I don't have my L. We got to do Pythagorean theorem to find our L. Oh, but I do have my radius. It's 8. So 15 squared plus 8 squared equals L squared. I have 225 plus 64 equals L squared. And that's 289 equals L squared. I believe that's 17. Is that what you guys got? Okay. Again, I got a nice, pretty clean number, 17 meters. I want to do base and perimeter at the same time. Perimeter is 2 pi r, base is pi r squared. My radius is 8, so it's going to be 2 pi 8, which is 16 pi meters. And pi 8 squared is 64 pi meters squared. So I put in all the work to find these 4 things because I'm going to need them to finish up. Remember that LA is 1/2 P times L, SA is LA plus B, and V is 1/3 B times H. So LA is 1/2 of 16 pi times 17, because that's my slant height. 1/2 of 16 is 8, so H times 17 is 136. Does that seem good to you guys? Good. 136 pi meters squared. Okay, that's not what I wanted, but that's fine. LA was 136 pi, and then base was 64 pi. That becomes 200 pi meters squared. Does that look good to you? Good. And then last 1/3 base was 64 pi. And then height, it says H, not L, so height was 15. I cannot do 1/3 of 64, but I can cleanly do 1/3 of 15, and that's 5. And 64 times 5 is going to be 320 pi meters cubed. Now I just realized why we ended so early. I want to go back and look at one small thing, but does anybody have any questions on the cones? I think cones, like cylinders, were the easiest part. Would you guys agree? I think the pyramids are the hardest. I want to do one of them where I find height on the pyramid. So let's go back. I think this one right here, the one with the hexagon at the bottom, I have a little space here, and I did volume in my last class. So we did 1/3 BH. We have B, but I don't have H. So I want us to practice seeing how to find the height in this picture. So in my hexagon picture, my slant height is this line right here, which we have labeled 18. My normal height would be up from the vertex down to the center. The third line that I'm missing goes from the center to where the slant height was, which is right here. That is the side that we labeled 4√3. So my little triangle here is 4√3 here. This is my height, which I don't know, and that is my slant height. So we have to find my vertical height, my perpendicular height, using the other 2 sides. Do you kind of see what we're doing here? So I had to know what this distance was. So let's do Pythagorean theorem for that. I can do it over here. So I've got H squared plus 4√3 squared equals 18 squared. Everyone okay with what I'm doing so far? Anybody want me to talk more about how I got here? 4√3 squared is 4 squared, which is 16 times 3, and 16 times 3 is 48. And 18 squared, I don't remember that, is 324. Minus 48 from both sides, and I get 276. Last class I let us just put in the calculator, but let's see if we can do the actual like factor tree it out. See if it divides by anything fun. Divide by 2. I get 138. Divide by 2 again. I get 69. I can't divide that by 2, but I can divide by 3. I get 23. Ooh, and that's perfect square. I can take a 2 out though. So this becomes 2 root 69. Oops, sorry. And then now that's my height. So I'm going to plug that in for my h, and my b is my 93 root 3, 96 root 3. I think I said that all wrong. And we're going to do 1/3 of that. So let's do it. 1/3 of 96 root 3 times 2 root 69. 1/3 of 96 is 32. And then I get to multiply the numbers outside the radical together. So 32 times 2 is going to be 64. And then I can multiply the numbers under the radical together. So 3 times 69 is 207. However, before we're done, we got to make sure 207 is as simple as it is. I'm going to argue it's not. To get 207, we just did 3 times 69, right? And 69 was 3 times 23. Do you see I've got a 3 I can take out? So this is like 3 root 23. And so I'm replacing all of root 207 with 3 root 23. I have to do one more step because I got to do 64 times 3 before I'm all the way done. That's 192 root 23, and this would be something inches cubed. Whew, that was a bit of a problem. See what we did there though? I just made us practice looking for the right triangle. This is not new stuff. It's not hard. I just made us kind of work through that algebra of it. All right. Anybody questions? That's all we're going to do today. So you have the rest of the time to get started on your homework, which is about 13 minutes. That's awesome. You guys did really well with this lesson. This is the last lesson. So when I see you guys online on Monday, we're reviewing. And when I see you in real life on Wednesday, you're taking a quiz, a test, a class, something along those lines. You're taking an assessment on chapter 11. Okay. I know that's not ideal, but I want to spend at least one full class period reviewing for the final. Keep your eye out on Schoology because I should have a final review up for you ASAP. Anybody questions, concerns, thoughts? Oh, zoom out. Let me zoom in from here. Okay, perfect. I'm going to stop my recording so nobody has to listen to